at this point we have our augmented matrix in row echelon form, which means that we have zeros in the lower left-hand side, and then we've got ones down the diagonal. But we're going to continue dealing with the augmented matrix. We could go through, write out our new system of equations, and use back substitution to solve for y and x. However, we're going to continue using row operations with the goal of getting zeros above the ones as well as below the ones. And we'll see that this ends up being very, very useful. So let's try and get a 0 here where the 4 is. So for this step, we are going to leave the first equation, the first row alone, 1, 2, negative 1, and 1. And we're going to leave the third one alone. But our goal is going to be to change this 4 into a 0. The way that we can do this is by taking this row and subtracting 4 times row C, because 4 times 1 is 4, and 4 minus 4 is 0. We don't want to do anything with the first row, because if we do that, we're going to introduce something in the first column. So we can only deal with subtracting a multiple of this third row to change that 4. So we're going to keep row B, and then we're going to subtract 4 times row C. So we've got 0 minus 4 times 0, which is 0. We've got 1 minus 4 times 0, which is 1. Notice that those don't change. And then we've got 4 minus 4 times 1. That's 4 minus 4, which is 0. And then we've got negative 7 minus 4 times negative 2. When we're subtracting a negative, that's the same as adding. So it's going to be negative 7 plus 4 times 2. It's negative 7 plus 8, which gives us 1. So now we're one step closer because we've got a 0 here. Now we want to get a 0 above it and then a 0 above that 1. So let's focus on this next step in turning this negative 1 into a 0. So we're going to keep the second and third rows exactly as they are. And we need to change the first row so that this negative 1 goes away. Well, what we can do to this first row is we can add the third row, row C, and then negative 1 plus 1 is 0. So we're going to replace this first row, row A, with row A plus row C. When we do that, 1 plus 0 is still 1. 2 plus 0 is still 2. And then negative 1 plus 1 is 0. And 1 plus negative 2 is negative 1. So we're one step away from getting it in the form that we want it to be in. We just have this 2 that we need to get rid of. Can you see how we can get rid of that 2? We're going to keep the other 2 rows the same. But to get rid of this 2 here, we need to take the first row and subtract twice the second row, because that will subtract 2 away from the 2 and turn it into a 0. So we need to take A minus 2 times B. If we do that, 1 minus 2 times 0 is still 1. 2 minus 2 times 1 is 2 minus 2, which is 0. 0 minus 2 times 0 is still 0. And then negative 1 minus 2 times 1 is negative 1 minus 2, which is negative 3. And so now we are in a situation where we've got zeros in the lower left, we've got a diagonal of 1s, and then we've got zeros above that. And if you don't see how this is helpful, let's convert our augmented matrix back to a system of equations. This first equation is x, and there's no y's and z's, so 1x is just x equals negative 3. The second equation, the only variable that has a coefficient other than 0 is y, and we know 1y is the same as y equals 1, and then the third equation gives us z equals -2, and we don't need to do any back substitution at all at this point. We have got our values of x, y, and z all on their own, and that is our solution. So in general, for Gauss-Jordan elimination, we want to get 1s on the diagonal, we want 0s to the lower left, and we want 0s above, and then we want some numbers in the last column, and when we do that, the system of equations become x equals some number, y equals some number, and z equals some number. So we don't have to do any back substitution. This just gets us to our final answer. Please take a look at the linked examples below for more worked out examples here. I know each example takes quite a lot of time, but you want to get through a couple of them just so that you get more confident with the order of doing things and the way that these row operations work and getting everything set up.